Hello everyone and good afternoon. My name is Sumak and I look after APAC sales for the Actility group. For today's session, I will provide you a quick overview of Actility, then discuss the role of LoRaWAN is playing in the utilities market. And I would also like to share a few success stories we've had in the APAC region. And then I want to quickly talk to you guys about how we're enabling DLSM COSM over LoRaWAN for metering use cases. And finally, hopefully we'll have some time to take questions as well. So Actility is a software company specializing in IoT, low power, wide area networks, specifically in LoRaWAN and also now in cellular IoT. The company was founded in 2008, and since 2012, we've played a pivotal role in the standardization, development, and evangelization of LoRaWAN. Our ThinkPipe product is the leading LPWAN IoT solution for public and private LoRaWAN networks. And it has connected more than 40,000 gateways, 5 million devices as well. In 2017, we acquired a company called Abiway, which specializes in LoRaWAN geolocation solutions tracking. And right now, it's been quite a good success for us. We're averaging around, I think now, close to 300,000 units sale per year. And earlier this year, Actility acquired a company called Actility, which has developed a SHIC protocol, which enables IP protocols to be used over LPWAN networks, including LoRaWAN. And this is a bit of a game changer because it opens up many use cases over LoRaWAN, and I'll talk more about it a bit later in the slides. So utilities are leveraging LoRaWAN to address a wide range of use cases, from leak detection to smart meter readings to smart grid management, flow and pressure quality. So there's a huge number of use cases that utilities are now addressing using LoRaWAN. And what is the reason for this? Why is LoRaWAN being able to serve so many use cases? It's the fact that LoRaWAN actually has become a bit of a game changer for the utilities from a technology perspective. The reason for this is that it has a number of characteristics which are interesting for them. One of the key strengths, for example, is the long-range capabilities that you get with LoRaWAN. And if you think about utilities, they have a lot of assets that they need to monitor, which are actually quite rural and in hard-to-reach places where traditional technologies don't exist, like cellular networks don't exist and cover the full infrastructure. So they can then leverage LoRaWAN's long-range capabilities to actually be able to connect and monitor their assets. Also for them, LoRaWAN they find is a cost-effective solution with minimal infrastructure requirements. It's allowing utilities to scale coverage on demand as they grow while keeping operational costs low. And one of the other interesting factors that I've come to realize is that they like LoRaWAN because it offers the option of full private network. So basically, it allows the network destiny to be within their hands. Many of them have been burnt in the past by public network shutdowns. For example, 2G and 3G networks that have been shut down by public operators. And they've had to then do expensive migrations of M2M or IoT sensors into other technologies. So by having their own private network, then their destiny is within their own control for, if they want to deploy a sensor for the next 10 to 20 years. So I'm going to also specifically focus on smart grid monitoring because it's increasingly being adopted for such use case. Utilities are using it to really be able to monitor, manage, and optimize their electrical grids. And we talked about this key advantage of having this exceptional range with LoRaWAN. And this is even more important for electrical grid utilities, which have assets, again, in very remote areas, rural often, in harsh environments where it's not easily accessible. And again, traditional technologies like cellular typically don't have coverage in those areas anyways. So LoRaWAN's long-range coverage ensures this remote substations, distributors, transformers, and other critical assets can be connected and monitored. So smart grid use cases can be categorized into 3 key subcategories in terms of the use cases I'm seeing. One is substation monitoring, which is very important as substations play a critical role in the electricity grid. Many substations are remote, and often the utilities don't have good visibility of their status. And they frequently need to actually visit them and inspect them, and it can be very costly to get people out there. So simple use cases like environmental and weather monitoring are being implemented at these remote stations, substations, for even like a basic thing like flood detection and monitoring, right? They're digitizing a lot of the existing analog sensors there to be able to capture more rich data. And access control is another use case that's become interesting for them as well. A lot of these sites, they're not manned, and they don't know if people are going into the sites and if they're legitimately going in there or for vandalism. So they can very easily put like door sensors and access control sensors on them and be able to be notified if someone's accessed the site as a planned work. Asset management in public areas is another key use case. So these utilities have a lot of assets such as electric poles, street cabinets, and even sometimes they manage street lights for cities. And they, again, don't have much visibility on these. For example, with the electrical poles, every now and then they do fall over. They're involved in maybe a car crashes into them. And they don't know about this until an outage is caused and they track down where the outage is. So by them actually putting a very low-cost sensor, for example, a sensor with just an accelerometer, they can then monitor these poles and actually see over time their degradation, but of course also if they fall over or involved in an accident, receive an alarm immediately and know where the service area is. Similarly with the street cabinets, they have almost zero visibility of what's happening at these, and what they're looking at, or some of them are doing, is putting, like, for example, temperature and humidity sensors to understand what's happening inside them. They're putting door sensors on them to know if they've been opened without authorization. And lastly, on the asset management in public areas, the street lights. I mentioned that some of these utilities in some parts of the world actually manage the street lights on behalf of the cities. And so they can, very easily they can turn them into smart street lights and connect them over a LoRaWAN network. The last key category is the grid optimization. So, many of these utility electricity grid networks have been built, 30, 40, 50 years ago. They're quite aging. They don't have good data on them. So what they're doing is being able to monitor them and understand the load levels and so on is becoming more critical. So having, metering, being able to do load management through automated demand response, being able to anticipate fault and actually remotely, understand where the fault is and where to go and service is becoming more critical for them. So Powerco is one of our customers. They're a New Zealand utility company. They have the second largest electricity distribution network. They're also the largest gas distributor, but right now they're really focusing on the smart grid use case. And they have a very aging grid, and this was the challenge for them is, how do we improve the resilience of this network through early detections of faults and anomalies. The second challenge they wanted to address was, how do we build a cost-effective private IoT network which they have full control over? So they'd been burnt a few times by the public operators in New Zealand where through the 2G network shutdown where it resulted in them having sensors in the field where they had to go and replace them. So they wanted to deploy use cases which may be in the field for 10 to 20 years, and they wanted to have full control over the life cycle management of the network. So they decided to deploy a full private secure LoRaWAN network within their own data center. It's powered by the Actility ThinkPark Enterprise platform. And they're now deploying sensors on power poles, lines, transformers, and they're collecting very interesting instrumental information vital to the network health and being able to now really be able to monitor and understand the health of what's happening within their grid. Tas Neworks is an Australian government-owned company overseeing electricity distribution across Tasmania. And their challenge was really around a lot of their assets being super remote in very rugged environments. They would often have to do very costly manual inspections. To get people out to some of these remote sites, they actually have to charter helicopters to get people out there. So they were looking for a long-range LPWAN technology which could help them manage these costs and be able to remotely monitor. And the other challenge they wanted to look at was, well, if we're going to deploy this LPWAN network, can we somehow also generate revenue from it? So they selected LoRaWAN as a technology because of the long-range connectivity. But they didn't have they understood that LoRaWAN deploying it at wide scale is not an easy job, and they didn't have the skill set. So they went to the experts in Australia, which is NNNCO, and they partnered with them to help them deploy the network. And additionally, what they've done is they've decided to monetize the IoT network. So they're now, through their telecom division 4224, they will start offering connectivity services to local councils, enterprises, and even other utilities as well. So they're using the network for their own needs, but then also sharing that network with others to generate new revenue streams. Horizon Power is a utility in Western Australia. They have over about 100,000 residents and 10,000 businesses, but these are spread over 2.3 million square kilometers. So it's making it the largest service area in the world with the fewest customers. So the challenge for them was tied to this issue of having this very large service area with small amount of customers. How do we establish a smart grid network for an extensive region? And the technological characteristics again they were looking for was long range, easy to deploy on demand, and easy to scale. So again, they didn't have the technical know-how, so they partnered with NNNCO in Australia to start on their LoRaWAN projects and testing and eventual future deployments. One of the other points that for them it was of important consideration was that they looked at other connectivity options as well, like cellular. And unfortunately, most of those regions that they have assets, there is no cellular coverage. Australia is a very big place, and unfortunately, only the main cities have very good coverage. So LoRaWAN was really the only option for them to be able to deploy on networks on scale. So I want to quickly talk about DLSM, COSM over LoRaWAN. This is a standardized communication protocol which is used in the utility and energy space. It's like a common communications language that allows different type of energy meters and other utility devices to communicate with each other. And DLSM COSM has really been a challenge for LoRaWAN. The challenge with it is that it has large payloads which exceed the LoRaWAN max packet size. And also DLSM COSM needs UDP or TCP over IPv4 or 6, which is not something that LoRaWAN can natively support. So there has been an ongoing challenge in the industry on how to solve the data size and IP connectivity to enable DLSM COSM metering for LoRaWAN. So this has now been made possible and solved by a technology or protocol, I would say, called SHIC. So SHIC is a specialized technology designed for compression and fragmentation, which are the two key crucial aspects for efficient data transmission over LoRaWAN. Compression is used to remove the overhead of carrying IPv4 and v6, and then fragmentation is used to solve the issue of the LoRaWAN packet sizes. So as you can see here, we've got the LoRaWAN stack at the bottom, and on top you run the SHIC adaptation layer, and then that allows the higher levels, such as the IPv6, the UDP, DLMS, to actually operate above LoRaWAN, and it operates transparently, so there's no impact to devices, to the ecosystem, and so on. And finally, just wanted to talk about one field deployment on this. So we've had a successful field deployment in the Ivory Coast with CIE, where they've deployed DLMS COSM in a field trial with two meter vendors. The two meter vendors were KFA and Vision. And they were, with electricity metering, there is a very high load profile in terms of the amount of data that's being captured and being sent over a network. So basically, these meters were loaded with very high profiles, and they were taking 30-minute samples being sent every hour. And there was an impressive overall read rate of 99% achieved by both KFA and Vision. So it's been very successful, and we are now, we have a proven technology which is very much standardized, working in the field, and we're working with a number of utilities to go ahead with larger deployments. So thank you all for listening to me, and you can find my contact details on the screen, and if any of you have any questions, I can be available at the back or here to take them. Thank you.